hopefully. Yeah, that's that idea. The idea about derivative, right? It's about learning a little bit in the future. Literally, if you're in finance, or no, not really accountant, but more or less like finance, okay, banker or something. But if you're in the back end, the one on the back, that forecasting the stock performance, behavior of the analysis of the stock, the company, anything, okay, those analysis basically derivative. I would say more than 50% of the work in analysis, in forecasting, the world is forecasting, predicting the market behavior, the stock behavior is about using derivative. Yeah. So yes, more or less studying derivative, eventually leading into predicting the future. Try to predict the future. Okay. But not today. That's too far away. Right? Today we're gonna learn how the derivative apply in real life. Just maybe one or two examples. Okay, so the air is pumped into a spherical balloon such that the volume increases at a rate 100 centimeter cube per second. Okay, so increasing at some number. Okay, 100 centimeter cube pumping into the balloon. How fast is the radius increases? When the diameter is 50 centimeter. Okay, so here are the key information in this problem. They give you the volume. Okay, they say something about that's about the radius. The question about the radius, and they give you the diameter. Okay. When you do this problem, first of all, you want to summarize the key information. Summarize the key information. The given information and the question. Usually you're gonna label, okay, jot down the key information, starting with the diameter, right? The diameter is 50 centimeter. Okay. Clearly, the question asks you how fast is the radius increase. Okay, how fast is the radius increasing? Is it this? Is this asking for the radius?
It's asking for the change of the radius.
Okay. Language, guys.
Okay.
Okay, how fast is the rate of change? Not really the radius, not actual radius. So the rate of change of the radius. In this case, how do we label that? Something with R, right? But not just R. Something with
time.
Okay, the rate of change, yes. D, yes, involve T there. The rate of change of the radius. In other words, R prime. We learned implicit differentiation yesterday. We applied the derivative to a bunch of different variables. S, T, U, V, X, Y, right? It's just variable. So now we're going to apply that. Now we don't have just X and Y anymore. We're going to have something more specific that relate to each problem. So in this problem, they ask for how fast is the rate of change of the radius. Rate of change is the derivative of the radius. There you go, derivative of radius. But derivative with respect to what? Time, right? Velocity is the derivative, the rate of change of the position, right? With respect to the position, dy over dx, right? This one, the derivative, the rate of change of radius with respect to time. There you go. Okay, R prime, basically R prime. If you can do that there. Derivative. Okay. They don't give you the radius. Do you know the radius? Right? Diameter is 50. Diameter is 2 times the radius. Right? twice the radius. So the radius actually is given. It's given to you. 50 over 2. It's just 25 centimeter. Okay. Okay. Next. We talk about this. The volume. The thing that connect these everything together is the volume. Okay. The volume, something about volume that relate with this number. Relate to that number. Volume relate to 100. What do they give you? Okay. My question is it is. Do they give you this? No, not really, right? Sometimes you can tell by the unit. Look at the unit. Centimeter cube is the unit volume, right? Square is area. Cube is something about volume. Cube over second. Volume over time. They give you dV over dt. There. Okay, or this word, the volume increases, the rate of change of the volume increases. This is about, one more time, this also this. How fast, increase, decrease, okay, slow, quick, right? Those words, those adjectives tell you the rate of change, okay? So, clearly, on the left side, are the given information. On the right side, are the one in the question. When you do this problem, the idea is this. You want to recall a formula that combine all of that. You want to develop a formula, not really develop, you're not going to come up with a new formula. You want to record some formula that connect the radius and volume, and then the object that you're looking at. One thing that you haven't talked about is a spherical balloon. And then they have something with volume of that balloon, something about radius of that balloon. Okay, so what would be your first initial thought? You want to find the volume of a sphere, right? Or a bone, right? Right. Volume of a bone, volume of a sphere. Okay. Let's trace back. Let's circle back. Circle. If you have a circle, some basic information you need to know. Some basic formula from the circle. First of all, the circumference. 2 pi r. The area. Pi r square. Okay. Now you go to 3D. You're gonna have a sphere, right? When we have 3D, we're going to talk about the volume of a 3D object. The volume, 4 over 3 pi r cubed. Okay. So 4 over 3 pi r cubed. Volume of the bone. Okay. Okay. In this formula, is connect. There is something with the volume in there, right? Clearly, left hand side, right hand side. Yeah, it has 4 over 3 a constant. Pi is 3.14, right? Another constant. Only r is the variable. Okay, and r we know r, 25. Okay, now the question, looking for this. One more time, recall yesterday, the implicit differentiation. Yesterday, maybe this, x squared plus y squared equal 25, the circle, right? The circle. And then the question asks you dy over dx, right? Ask you that, dy over dx. What did we do? We take derivative both sides, right? Until this one show up, and then we show for that one. Okay, this one gonna show up on your exam today, extra credit, something like that, right? So, okay, so we're gonna practice for your extra credit today. This question, you have this, V equal 4 over 3 pi r cubed. The question asks you to find this thing. Then I don't know where's that. I don't know what's it look like, but I know the idea is first take the derivative both sides, or in other words, implicit differentiation. That is the first step I'm going to do. I'm going to derivative both sides. So, okay, put the d over, but this time, remember, d over dt with respect to time. Okay, I'm going to drop the letter ball. Okay, I keep the letter v. Okay, I keep the important thing. Okay, d over dt 4 pi r cubed. Okay, in other words, that is a high derivative both sides, right? Put a prime, don't put a prime, put this. Okay. Why I use this? Because I'm careful with this. If you put a prime, you don't know you are in derivative with respect to which variable. You don't know which variable you taking derivative with respect to. When you write like this, the Leibniz notation, you know that you are taking derivative with respect to t. Okay, and that is very important. That tells you the answer. Yeah.
Would it be d over dt of 4/3?
Oh, 4/3. Oh, thank you. 4/3. Thank you. And because that dt, that will tell you the answer for the next step. That dt is important. With respect to time. Left-hand side first. Left-hand side. What do you think? Is it 1? Not doesn't seem right, right? 1 is not right. What do you think? Is it a constant? Is V a constant? If it's a constant, it's going to be 0. Is it a constant? Do you know V? No, you don't know V. Okay. Y, if I ask you to put dy over dx, yesterday we have dy over dx. We return the same thing because we don't know. That's y prime. Okay. dy over dy. That is 1. Why? Matching. Then you can use the formula. Not matching, then you don't know. Not matching. dv over dt. Okay. Okay, now right hand side. That 4 over 3 pi. This one, the yellow, are constant, right? Constant. So I'm gonna throw the constant outside. 4 over 3 pi d over dt q. Right? Okay. Left hand side, dv over dt. Leave it there, because I don't know. Okay. 4 over 3. Copy. Paste. 4 over 3 pi. How about this? It's just a variable. It's just some letter. X or Y. Okay. Imagine if I have d over dx, y cubed.
dr squared dr over dt.
There you go. Correct. Okay, I'm going to lead you to that one. Okay, so if I have this, you're going to have 3x squared, correct? Right. Okay. Yesterday, we have this dy dx. Right? Three r square dr over dt. There. Okay. We never forget the question. The question, look for this. By doing implicit differentiation, it pop out. It's right there. Right? That, basically, the rate of change of the radius. It's right here. So in other words, this whole thing, everything in front, shift to the left side, do some algebra to the left side. We solve for that. Okay? In order to do that, in order to do this, we can either plug in a number now and can solve, or we can shift to the left and then we plug a number in. Which one do you want first? Plug first or plug in later?
Later.
Plug in later. Okay, plug in later. So now I'm going to solve for this. So for this, right now I'm looking at the multiplication. This times this times this times this times this, right? So to move to the left side, what do? Just one operation, dividing. Just one operation. Divide. Basically this whole thing, 4 over 3 pi 3 r squared divided by 4 over 3 pi 3 r squared. I was very bad at doing this one. I should have cancelled this 3 and 3. Okay, that is careless from me. Okay, cancel 3 and 3, it look nicer. Okay, instead of writing like this. Okay, so dv over dt divided by, okay, now I'm going to cancel, completely gone. 3 over 3, go out the window. So 4 pi r squared equal dr over dt. Okay, so far good? Any question? We're there. We're really close, really close. To find, to answer the question. To answer this question, to answer this, we need to find out this quantity. How many things do we need to identify in here? R is one thing. Do you know this? dv over dt, do you know this? Yes, you do. I'm going to use color, Purple one is 100. dv over dt, that purple is 100. R, 25, correct. 25 there. We have everything on the left hand side. Plug in a number, you get your answer. Okay, so 100, which is the purple, divided by 4 pi 25, which is the teal color. In fact, it's 25 square. Okay, anyone have a, now when you do this problem, yes, you need calculator. But actually, drop it before using a calculator. You can do this. You can do it. 100 divided by 4? 25. Top or bottom? Okay, I have 25. Top. Pi on the bottom. 25 down here square, right? Okay, maybe I'm going to jump down here. 1 over 25 pi. Okay, there, that's a really nice answer already. And convert to decimal.
Why did you get a 25 in the denominator? Like, where did that come from?
You mean this one?
Uh-huh.
From the radius? Yes, okay. Because right here, the diameter is 50.
Oh, just 25.
Uh-huh. That is diameter, right? The radius is half a diameter. Half of 50 is 25. Okay. Any other question? Keep asking. Yep. Never think. Remember this. When you study, this is, I would say, a blood experience for me. Okay. when you study, never assume any question is too obvious. Don't think you be Captain Obvious when you ask a question, no matter how obvious. It could be obvious to somebody else, but it's not obvious to you, then you ask. Don't be shy. Okay. Knowledge is endless. Okay. You need to ask, you need to, okay, sometimes when people answer the question, when your professor answer the question, it can be obvious to you, but the moment before that, it's not. Then ask. Okay. Don't be afraid that, okay, everybody, maybe I have a bad question, blah, blah, blah. People are going to be laughing at me, if my friend laughing, why you answer the question? Nope, never. Okay. Keep asking, right? And that's true. I wish if I could turn back time, I could have asked more questions. Okay. But I didn't. All right. Okay. So we have the answers right there. Now, help me use a calculator. Give me maybe a decimal number. How much is that? 1 over 25 pi. 1 divided by 25 pi. 1 over 25 pi. 25 times 3.14, 75, 76 something. 1 divided by 76 something, right? 77. 0.013. Around there. Okay, okay. Now, for this particular problem, for this section, or not the problem you're about to do will be real world application. Real world application require unit.
Well, you cancel out the 25, the surrounded 25 with the 25 on 5.
Oh yes, okay, okay. Okay, so 100 divided by 4 is 25, I read, right?
Yep.
The 25 square, another way of writing 25 is? 25 times 25. Now I'm going to cancel one of them. So I have 1 over 25. Good, good. Okay. Okay. So, yeah, I know I'm out of question. Go ahead, go ahead. So I have 0.13 or the other one. Either one of them are good answer. Now let's talk about unit. What will be the unit of this? Okay, in order to answer this, if you can recognize this, then good. If you can't, go back to the question. What's the question asking? How fast is the radius increase? Okay, let's drop on the calculus thing. Drop on of that. Just purely common sense. If somebody asks you how fast you're going, how fast something pouring, how fast you speeding through the red line, right? Right? Police call you in. How fast did you floor over the school zone, right? Normally. Okay. How far did you bottom up last night? Okay, everybody stay hangover, right? Okay. How far did you bottom up last night? Usually, how do you answer those questions? Something, okay. Something over something, right? How fast? 100 miles per hour, right? Okay. That's technically chill. Literally, that's chill. Okay. I did 90. I did 90 on my motorcycle. Okay, I did 90 on my motorcycle. Yeah. It's scary. Yeah. My driver license suspended for that one. Okay. Yeah. So yeah, yes, true. It's true. Yeah. Can have it. I pay for the whole odometer. I'm going to use the whole odometer. But that is way in the past. Okay. Don't make that. Okay. Anyway, so that 100 miles per hour. How many bottles you drink last night? 5 bottles per hour, blah, 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 right? For this problem, what do you think? Centimeter per second, right? The radius expanding, right? The radius of the balloon. You blow in, smaller it is. Every second it's getting bigger, right? How do you say that? Expanding 0.13 centimeter per second. Really little. just like this every second, getting bigger and bigger. Yeah. Okay, that's one way. Look at the question. So I tell you the unit. Another way is over here. The radius, that tell you the radius over the second. Radius over the second. Unit of radius, centimeter. Unit of second. Unit of time, second. There. That's also tell you the unit. Okay. Exactly how you develop the volume. The volume increasing 100 centimeter cube over second. By looking at this, unit, I know exactly that is the volume over time. Right? The unit tell me which it is number 4. It's not volume. It tell me that is the volume over time. Therefore, it's going to be dV over dt. 100 is dV over dt. Okay. All right. Okay. Okay. Any question? Good. Any question? I want to show you something. I want to make a connection. When you take the derivative of this, right hand side, here's something extra. Technically the problem done. I'm going to give you something extra. When you take the derivative of this, you have this, right? You have that. You have that thing. The right hand side. Let's say if I cancel that. So you have 4 pi r squared. Okay. So dv over dt, 4 pi r squared, dr over dt. Okay. I drop that dr, I'm going to focus on this quantity. Four times the area. That number 4 eventually going to be cancelled. If you eventually you're going to do math in Calc 3, that number 4 cancel. In other words, a 3D object, when you take the derivative, it returns the 2D object. 3D return you 2D. Derivative, this one. Tell me the answer. What do you think? The area. What would be the answer? 2 pi r. Circumference. Circumference is the length. What is circumference? The whole circle, right? You cut the circle. You cut it. Look like a string, right? You cut it. You lay it out into a line like this, right? That line, the length of that line, is 2 pi r for every circle, right? The length of that line is 2 pi r. In other words, that is 1D, right? 1 dimension. 2 dimension derivative. 1 dimension. 3, 2, 1. Another application of derivative. Much more advanced in 3D. And then by doing this, if you reverse engineer, okay, you go forward, you keep going forward. You can go to 4, 5, 6, and that's how they learn n dimension thing in object thing. Okay, very advanced. But you're gonna focus on these 3 in Calc 3. Okay. Why? What is the connection between derivative in terms of object, in terms of geometry? Okay. All right. I think that should be good. Just one example. Just give you a warm up. And also this example, remember this technique right here. The implicit differentiation. This one right here. Okay. Later you're gonna do the extra credit in the quiz, in the exam. Try this. I hope you can try that. Okay. All right. Sounds good? Ready? Exam? Okay, so let's do the exam. Not the group one. Okay, so you can still keep your, okay, sit in your place. Okay, we're gonna do the exam. Okay. No no cheat sheet, right? No cheat sheet for the first part, the individual. However, I emailed you yesterday, and I told you that I will give you the formula. Okay, so the formula exacted. Okay. Okay, so the rest you should be know. You should be know. Everybody should know.
Hey, I'll take the crayon. Can I fill that?